In this video I will refresh your memory about the concept of place value and the concept of trading for addition and subtraction. The reason why I have money on the paper here is because I'm gonna use money to model the concept of trading. So the place value concept first. It is so important to do any kind of mathematics that I can't overstress it enough, the importance of this. So for example, in the number 1,234,567, I spaced my numbers a little bit so I can write around it. 1,234,567, the digit 7 stands in the 1 place value. I understand that this is a digit 7 and that's a digit 1, but the meaning of this digit 7 here is that it represents values that's counted one by one. So if I was just ignoring all of the rest of this number in the magnitude of million and just looking at the digit 7, it has a value of 1, and I think it could be represented well with $1 or 1 apple or 1 of anything, but that is its place value. Okay, and the meaning of the 7 is that there are 7 of these. I don't have 7 $1 coins for you, but that is the difference between the concept of place value and the actual number that you're seeing. It's important that you make this distinction between the two. The next one in this number here is the digit 6, and the digit 6 has the place value of 10. The meaning of this 6 is that there is 6 of them, but the value of that 6 is 10. That's why I have there a $10 bill here. And the digit 10 here is not the same as digit 6, but the difference between the two is that this 10 represents its place value and this represents the number of items. So because I wrote 6 here, it's not just a 6 alone, it means 60, because it has a value of 10. Okay, if this had a value of 1, it would just be 6, but because this number here, the 6, has a value of 10, the meaning of this is 60. The next number is 5, and the digit 5 has a place value of hundreds, and the pattern continues likewise. The digit 5 is not the same as the number 100. The difference between the two is the difference between the two concepts. This 5 doesn't mean 5 loonies or 5 apples, it means 500 of them. I don't have a $100 bill, but I think you get the idea that the place value indicates the value of the digit that the digit indicates by its place in the number. The number 4 here has a place value of thousands. When we again read it in a number, 1,234,000. The digit 4 here has a place value of thousands. The 3 has a place value of 10,000. I'm gonna write it here, 10,000 for the digit 3, that one. And for the digit 2, this one has a place value of 100,000. I'm just gonna separate it with a little comma there. And the digit 1 at the front here has a place value of 1,000,000. I'm gonna write it up top here. 2, 3, 4, 5, 6 zeros. That's 6 zeros, ladies and gentlemen. And no, a 6-figure number doesn't have 6 zeros. A 6-figure number has 5 zeros. Yeah, take a look at this one. 100,000. It has 5 zeros. 1, 2, 3, 4, 5. And the 6th figure is a 1. Okay. Now, trading. I'm gonna draw another number here. Write it up. Say a 2-digit number. Say 23. Now 3 in the number 23, 3 is in the ones place. I'm just gonna write down the 1 here, and 2 is in the tens place. So that means we've got 2 $10 bills, and I'm just gonna write down, here is a 10 spot and here is another 10 spot. There's the 20 bucks. And 3 loonies, and I'm just gonna go 1, 2, 3 loonies. Okay, 20 bucks and 3 loonies, $23. Now, when we trade for addition or subtraction, it's also called regrouping or borrowing. This is what's actually happening. You take one of the tens and you change it into loonies. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You change it into ones. Okay, so I'm gonna rewrite number 23 now. It's got one $10 bill left, and we've got all those loonies, 13 of those loonies. So 23 is the same as 1 10 and 13 ones. Now, normally we do not write numbers this way. This is only used in subtraction or addition, because this format changes the concept of writing the numbers in their correct place values. But for addition and subtraction, 23 could be traded for 1 10 and 13 ones. Okay, let's do one more example for trading. Say $251. It's got $200 bills. There we go, $200 bills, 5 $10 bills, 10, 10, 10, 10, and 10, 5 $10 bills, and 1 loonie, a $1 coin. There. So if we want to trade any of these amounts, it's done using the same principle. We're crossing one of these out, and this makes immediately 3, 4, 5, 1, 2, 3, 4, 5, 10 $1 coins. So we could write, instead of 251, we could write 251 and cross that one out, and write 4 above it, and cross the 1 out, and write 11 above it. That's how it's written for addition and subtraction. So 251 is exactly the same thing as 2 hundreds, 4 tens, and 11 ones. Going back to the 23 for a sec, 23 is exactly the same thing as 1 10 and 13 ones. But if I wanted to represent it with the way it is in subtraction, you cross out one of the you cross out the tens and you take away 1 from it, and you cross out the ones and you add the 10 there. So that's how it appears in addition or subtraction problems. We could do trading with hundreds as well. We could trade 100 into 10 tens. Say there's one of them. 2, 3, 4, 5, 6, 7, 8, 9, and there's 10 $10 bills. And it is possible to rewrite the number 251 this way, that we took away one of the hundreds and we added it to one of the tens. So now we have one $100 bill, 10 pieces plus 5 pieces of $10 bills, and one loonie down there. We can regroup or trade the same number twice, and I'm just gonna rewrite it on this side of the paper again. So we started with 251, and we can trade twice. So instead of 5 tens, we can have 4 tens, and consequently 11 ones. And we can trade again. Instead of 200, we can have only 100, but then the number of $10 bills increase and become 14. So instead of 251, we can also write 1, 14, 11. And that's how the numbers are written up for trading for subtraction.